Vignesh, we can start now.
Yes, sir. We are live, sir. You can start.
Okay, great. Thanks. So anyway, it seems like a very small group here. You can, if you want, you can keep your camera on and you can just ask any questions you like. I think Arav already had a question, though it was not a. Yeah, yeah, we are starting. So one sec, I have to mute this. I have to mute this. Okay. Yeah. So yeah, I guess Arav had a question, but it was not mathematical. Do you want to ask it again, Arav?
Yes, sir. Just a second.
Yeah.
Sir, I am currently preparing for the advance. So I have joined this course to get some benefit regarding my preparation. So how this course can benefit me
So that means
regarding
you're
my.
in class 12, is it?
Yes, sir.
You are in class 12.
I am a dropper student, sir.
A what?
Dropper student, dropper.
Yeah.
I have done class 12th in 2021 and I have secured 97% in my board exam.
Okay, so you're just preparing for JEE.
J advanced. Yes, sir.
Yeah, this is more of a. This is not so much a JEE kind of course because there the problems are a bit different type. This may be
Yes, sir.
more in line with it may help you with maths Olympiad.
Yes, sir.
But I don't think. I mean, at least okay. I took JEE some 30 years ago, so I don't remember. But if I remember correctly, JEE problems are quite different. So
Sir, I
there.
have watched your some videos and I have solved the week zero assignment. So something linkage of P and C problems are there, which are usually asked in JEE.
Yeah, but I think anyway, I mean I don't know. If you're enjoying the course, you should take it. I'm not sure if it's the most efficient way to prepare for JEE.
Yes,
But if you want to do well in maths at JEE, you should learn a lot of
yes,
maths.
sir. Maths is my interest,
Okay. Then
so I want to excel more in that.
then you should also be applying for BMath and CMI. So yeah. Anyway, I hope I did answer your question very well, but that's all I can say now. If you have any questions about the first week or second week lectures, or
Uh,
anything like.
yes, sir. I am pursuing that, but some a little bit problem. So I am addressing it, trying to address it my own. As till now, I didn't have any query regarding the week one or week two because I haven't totally watched the sessions. So
Okay.
uh,
So you can use the forum also to ask more questions. This applies to
yes, sir.
everyone. Yeah. So well, I guess you have you don't have any other questions. Maybe
Till now, sir, I don't have any question.
okay. So maybe next
For
session.
next time, I can have more doubts regarding the
Okay.
course, but I am still enjoying. At when I get free time, I usually have to watch your lectures, which increase my some math skills.
Okay. Good. So any other questions? Okay. So my voice, Sandeep and Josh. Can you hear me clearly? I guess you're on the YouTube. Uh, it, yeah, it may be a good idea if you're on YouTube to just join the. If you want, you can join the uh, Zoom thing. Maybe easier to communicate because then you can even speak. I'm just giving the Zoom link on the YouTube thing. So yeah. Okay. So any other questions? Suhas had some comments on the forum. Suhas, did you see my response?
Yeah,
Sir,
like
your voice is low.
Yeah. Oh, okay. Let me see. I thought I increased the volume. Let me try again. Is it better now?
Yes, sir. It's more better.
yes,
Okay.
yeah. So in that the example that you gave, x2k is less than equals y. That
That's the example you
actually
gave.
does not hold.
Yeah.
Yeah, you are saying that
Yeah.
the partial order that I defined does not satisfy antisymmetry, is it?
Yeah. Yeah. It doesn't look like that,
Uh,
right?
but it does actually. If you read the condition, I say x2k is less than equals y if and only y equals x2k.
Okay. Let's write down that.
So y cannot be any integer.
Let me just. So so let me just share Suhas's. So you had Z union x to k is an integer, right?
Yeah,
And the rules are k is less than or equal to x to k. No, k is less than or equal to maybe a is less than or equal to xb if a is less than or equal to b.
yes,
Then of course a is less than or equal to b if a is less than or equal to b in Z.
yeah,
And x a is less than or equal to xb if and only if a is equal to b,
yes.
and x a is less than or equal to b if and only if a is equal to b.
No. So this never happens. Like xa is never. Uh,
Oh, x a is never less
yeah,
than or equal to b.
yeah,
Okay, so let's try drawing the Hasse diagram of this. So
yeah,
this is not a condition. I
yeah.
thought that was a condition. So
So I mean, how I wrote it is like xa is less than equals b. I mean y if and only if that y is xa itself, like that.
oh, okay. I misunderstood. Okay.
Yeah,
So it looks like this. So okay, so when it's always easier to visualize a partially ordered set if you just figure out the cover relation. So here we have this, and then we have xb is less. Okay, so a is less than or equal to. So this is x. We'll have x2 here, and we have 2 is less than or equal to x2, right?
yeah,
0 is less than or equal to x0, 4 is less than or equal to x4, and so on. Okay,
yes.
and maybe x minus 2 here. Okay, so this is the partially ordered set. And what was your automorphism?
Z. I mean, yeah, Z acts on this
Okay,
by where I sends uh,
a2.
A to A plus 2i and xa to xa plus 2i.
Okay. So maybe okay. So okay, I misunderstood. I thought that last was
That 2i is in subscript. Uh, the
x.
subscript becomes A
Oh,
plus
okay.
2i.
The x's are
Yeah.
shifted and the integers are.
Yeah.
Okay. And then you saying that the orbits are just.
Yeah. So the orbits will be even numbers, odd numbers, and these xa's, I mean x2k's.
Yeah. Okay, I see. Yeah. There's the issue here. Okay, good. So it looks like there's extra hypothesis is needed in problem 4. Yeah. But 4b seems to work.
Yes.
Okay, we leave it at that. Maybe if others are trying it, you should just look at the discussion in the forum. Anyway, this problem is maybe sort of out of syllabus. It has more to do with group actions and things like that. Don't concern. I mean, maybe not really important part of this course. Okay. Yeah. Any other questions? Maybe from Suhas or from anybody else.
So I have a question that can I ask?
Yeah.
So what are the basic requirements to understand this course?
That's already given in the course web page, right? I think basically you need to know a little bit about algebraic structures, not strictly needed, but it will be good if you have seen things like groups and rings before. Linear algebra, you should be comfortable with linear algebra, matrices,
Means
vectors.
one must have the basic knowledge of like that the bachelor, the things which study in bachelor degree of mathematics.
That's right. Yeah, undergraduate level algebra.
Undergraduate level.
Yeah.
Words.
So I don't know what your background is. If maybe depending on your background, some part maybe, but many things don't need any much any background.
I'm trying.
Yeah. Okay, so I don't see any questions either on the YouTube or here. If there are any questions, you can just unmute yourself. Maybe it's still a bit early to have a live session. Yes, Sudeep, any questions?
Sorry, sir?
Sudeep, you have any questions?
No, sir.
Okay, if there are no
Sir,
questions.
I have watched your lecture 6. In that you have given a homework. Can you
Week 1, lecture 6, is it?
week 1 lecture 6.
Let me see where is that.
Induced subposet. I have notes regarding that. I have made notes.
Yeah, okay. Week 1, lecture 6. Yes. This is the one.
Then Q is the subposet, induced subposet, such that Q divides
Q under the divisibility.
Q under the divisibility.
Yeah. Yeah, so you want to find some subset of positive integers, right?
Yes, sir.
There should be 8 of them.
8 of them because the power is 3. It's
2
quite
power
visible.
3 means what is this 2 power 3? This partially ordered set, what does it look like? So 2 power 3, let's draw the Hasse diagram. So all subsets of 1, 2, 3, right? So 1, 2, 3, the full set. Then there are 3 subsets of size 2. And then there are 3 subsets of size 1. And then there is one empty set. And the Hasse diagram looks like this.
Okay. So only Hasse diagram was the question regarding that.
No. So wait a second. Now I want to find 8 integers, 8 positive integers, right? Such that if you write down which is divisible by which, so you have to find 8 integers. Maybe I'll call them n1, n2. Maybe I'll just call them, so 8 integers. I'll give them names n phi, n1, n2, n3, n12, n13, n23, and then n123. So you have to find 8 such numbers, such that if there is a line going from here to here, then this number should be divisible by this number.
Okay.
So you want n12 should be divisible by n123.
Mhm.
n1 should be divisible by n12, and so on. There's no divisibility here. So whenever there is a line, you should have divisibility. So can you find 8 such numbers which has this pattern of divisibility? Let me do a simple example. Suppose I want 4 numbers, let's say n12, n1, n2, and n empty, and I want 4 numbers such that if so here's the answer. Okay, so I want to know n empty is divisible by n1 and it's divisible by n2, n1 is divisible by n12, n2 is divisible by n12, and I don't want any and yeah, so and they should all be distinct. So here's a solution to that, or maybe you can think of a solution. Can you find 4 such numbers? So one thing you can do is, maybe you can just take this to be 1.
It can be 1. And
now put 2 numbers. Anything is 1 is divisible by anything, so put 2 of your favorite numbers here.
7 and 8.
Excellent. Okay, and now I need one more number.
56.
Exactly. So very nice. So that is example, a solution. This is actually the isomorphic 2 to the power.
Okay, I've got it.
So now you have to do it for 3.
Now it's 40. So can we get any one?
You can now try to get all the examples also if you want. So just thinking of a simpler problem.
Interesting.
So one question is, what are all the possible partially ordered sets that you can get inside positive integers with divisibility? So that's a question that one can ask. Any yeah. So any other questions? Or something in the chat? Yeah. So we'll have one more live session after 2 weeks for sure. And if you want it even after 1 week, just put requests in the forum and so on, and we try to arrange that. Let's see. There's one more example from Shaban Malik. 2, 4, 8, 16. That's interesting.
2 to the power 2.
Let's look at that. So that is for okay, that's a very interesting example because it is actually not what I meant. So Shaban, I suppose Shaban, you're are you here? I mean, you could just
Sir, yes, I'm here.
So you're talking about the problem with 4 numbers, right?
Yes, sir. Yes, sir.
Yeah. Okay, I'm glad you brought up that example, because there is something little strange about that. So what you're saying is, so it actually points out a mistake that I made while explaining the thing. 2, 4, 8, 16, like that.
Yes, sir.
Yeah, so that's very good in the sense that these conditions are satisfied, but actually this is the poset 2, 4, 8, 16. There are more divisibilities satisfied. So I should have said that n1 is not divisible by n2 and n2 is not divisible by n. Otherwise, what is happening is that in this partially ordered set, there are more. So 4 is less than or equal to 8. Yeah, but here if I want this if I want this poset 1, 2, and 1.
Sir, your screen is not visible.
Oh, so sorry. Yeah, one sec. Yeah. Uh, yeah. Sometimes I forget. Okay. Yeah. So what I'm saying is, let's look at this example that Shaban put. So he says you can put 2, 4, 8, 6, and actually, according to what I said, he's perfectly right. I should have said something more. So so this is a partial, but actually, there are more relationships between 2, 4, 8, and 6. 2 is divisible by 4, of course, but also 4 is divisible by 8, and 8 is divisible by 16. Whereas I want 4 numbers which satisfy only divisibilities here. So actually I should add here the condition. So earlier I had only written 4 conditions, and that was a mistake. I need also this condition and this condition, because as partially ordered sets, these are okay, so this partially ordered set, and let's say Arav's partially ordered set, which was what, 1, 7, 8, 56. These are not isomorphic as partially ordered sets, because to construct an isomorphism, you need a function. You need to construct a function f from 2, 4, 8, 16 to 1, 7, 8, 56, such that firstly f has to be a bijection. Oops. F is a bijection, and the second is that A divides B if and only if f of A divides f of B. You need the divisibility here, relation here, to be equivalent to the divisibility relations here. But here you have 4 divides 8, but here you don't have 7 divides 8. So no matter how so of course, suppose you want to construct such a bijection, you have to map 2 to 1, because these are the least elements, and you have to map 16 to 56. Here you may have a choice whether to map 4 to 7 and 8 to 8, or 4 to 8 or 8 to 7. But no matter what you do, this condition here will not be satisfied. You will have a relation here which is not present here. There are more divisibility relations here. Here, in fact, 2 is less than or equal to 3 things, but 4 is also less than or equal to 2 more. 2 is less than or equal to 4 things. 4 is less than or equal to 3 things, and here 7 is only less than or equal to 2 things, and 8 is also only less than or equal to 2 things. That is 8 and 56. So, but this 4 is less than or equal to 3 things, and so these are not isomorphic as partially ordered sets. So the idea of isomorphism is that you have some structure and it exactly preserves that structure, and here it is not preserved. So maybe we can go and look at the definition of Oh, stop here. 1 second. Yeah, so anyway, I hope that clarifies that.
Yes, sir.
Let me just go and see isomorphism of both sets. Yeah, so this is the definition, right?
Yes.
The bijection should exactly preserve the structure. So here's an example of an isomorphism, and what we saw was an example of a non-isomorphic partially ordered set. So here's another interesting exercise. There are a lot of properties which are preserved under isomorphism. Any property which involves basically talking only about the partial order will be preserved under isomorphisms of partial order. And so if you want to show that two partially ordered sets are not isomorphic, you have to point to some set order theoretic property which one of them satisfies and the other doesn't. So in that example which we looked at, one of the posets had an element which was less than or equal to 3 other elements, the other did not. So they cannot be isomorphic, because if there was an isomorphism, if here you have an element that is less than or equal to 3 other elements, there also you must have its image must also be less than or equal to 3 other elements, because you have a bijection which exactly preserves partial order. So okay, so anything else?
Sir, can you please explain again the example 3 of week 1, lecture 1, Mobius inversion? The table, a little confusing for me. That was because I am unable to think the application of that.
Week 1, lecture 1.
Example 3 table. With this table, sir. Example 2, sir.
Oh,
This table.
yeah. So I mean, the problem is without talking about partial orders and so on. Suppose if you want to think of a function. So what are we talking about? We're talking about a function on n cross n to c. So you can think of such a function as maybe as an infinite matrix, right? So for each of these places, you have to give some complex number, right?
Okay, sir.
So we'll just call those complex numbers a00, a what am I saying, 01,
A0,
a02,
A02, up to so on.
a10, a1, or maybe I'll call them f and g, not a and b, because anyway the functions are also called f and g.
F and G.
f00, f10, f20, f. Oh, what was it the other way around? 10, 01.
F0.
It's the matrix. Yeah.
0 point was.
And the question is this: suppose you know the sums of all these rectangles. I don't know all the numbers, I only know the sums of these rectangles. So I know f00, I know f00 plus f01, I know f00 plus f01 plus f02, I know f10 plus f00, I know f11 plus f10 plus f01 plus f00. So I know all these sums. Can I get back? How will I get back these individual numbers? So this is the G matrix. So Gij, G is the sum of all the f's which are to the left and below, left and above x1, x2. So how do I get back the original array from this array of sums? Okay, this is a slight generalization of example
Mobius
1.
inversion.
And if you think about it, the answer is here. This is the answer. You just think about it. You just substitute this for all these values, and you'll see that all the terms cancel out except one term which becomes negative 2 times, so you have to add it back. So, oh wait a minute, is there something wrong here? Should this be? This should probably be just plus. I think this should just be plus.
Yes, sir. It was the confusion, sir.
Ah, typo there. Yeah, there should be just plus.
It's looking like De Morgan's formula in set theory.
Yes, exactly. Yeah, yeah. It is actually a special case of De Morgan. Whatever.
Okay.
Inclusion and exclusion.
Inclusion and exclusion theory.
Yeah, there is no 2 there. Good you asked. Yeah. I'm surprised nobody noticed it.
It was the confusion, sir. Now it's clear.
Yes, now it's correct. So, yeah.
So when I got the time, when I used to have lunch or dinner, then I used to watch your lectures at the moment. After then, or at the night of either 1 a.m. or 2 a.m. at night, I used to make the notes and revise. So a little bit I am knowing about the course. I'm trying my best to get knowledge about.
But if you really like mathematics, you should be applying to ISI and Chennai Mathematical Institute also for college. Let's see if there anything on YouTube. Okay, there seem to be no more questions. Arav, any more questions? I like your question.
So in lecture 5, the program you have made is that of like something like as a Python code. So can you explain it again?
Let me see. I don't.
Minimal, maximal, minimum, greatest theorem.
Yeah. One second. Let me just find that.
It was a little bit confusing for me.
Lecture 5.
Lecture 5. Maximal, minimal, greatest, least.
Yeah.
Yeah, this program, sir.
Yeah. So I just wrote it in Python
Above
style
programs.
pseudocode.
Yeah,
So it's just
slide 2.
it's a very
Previous
simple
one slide.
algorithm.
Previous one slide. This. Sir.
Yeah. So like take a, suppose we are more familiar with the ordered sets. Like say you have 100 students in a class and you want to find the tallest student, then what will you do? So you look at all the students and ask, is there somebody, you take one random student, start with any student, and you ask, is there anybody taller than this student? Okay, if there is somebody, then you take the student and throw him or her out of the room, and now you have this taller student. Then you ask, is there anybody taller than this student? Okay, and if the answer is no, okay, this is your tallest student. Otherwise, you find that other tallest student, throw this student out of the room, and in the end, either you will have found the tallest student or the room, at some point you'll find that, because it's finitely many students in the room. Okay, so the same idea works for a partially ordered set. Suppose you have a classroom and you have students who are playing say table tennis and badminton, and you want to find a person who is better at both table tennis and badminton. Now it could be that two people, one is better at table tennis and the other is better at badminton. So this becomes a partial order. It's not like the usual order of integers or something, but the same algorithm works because of the way we define maximal element. So maximal in this case will just mean somebody, so that you cannot find anybody who is better than this person at table tennis and at badminton. So maximal has a, so in a linearly ordered set, maximal is if you are better than everybody else, you are maximal. But here it is slightly different. So there's a difference between largest and maximal.
Difference.
Okay. So this algorithm is a, actually there's some subtlety here. It will find a maximal, but it will not find largest. There may be nobody in the class who's better than everybody at table tennis and badminton. So it may not even exist. For example, you could have a class where half the students only play badminton and half the students only play table tennis. And those who play badminton will beat all the students who play table tennis at badminton, and the other way around. So then you will not have any greatest element, but you'll still have maximal elements. The best badminton player will be maximal and the best table tennis player will be maximal. So that's the difference. So there's a difference between maximal and largest, and similarly there's a difference between minimal and least. And this difference only becomes evident when you talk about partial orders. It's not there when you talk about ordinary, linear orders, like where you have x is less than or equal to y or y is less than or equal to x. In partial orders, neither of these may hold. So that's the big difference.
Now it's more clear.
So that's.
So sir, in this case, we get multiple answers for the maximal or the greatest. Maximal. I mean,
there can be multiple maximals. Yes, maximal is not unique. Greatest is unique. Least
and maximal is not unique. There can be multiple.
Yeah. So you can also always draw the, you can draw Hasse diagrams and see these kinds of things. So for example, if I take proper subsets of 1, 2, 3. So that is the same as what I drew earlier, except that 1, 2, 3 is missing. So I have 1, 2, 1, 3, 2, 3, 1, 2, 3 and empty set. And now the point is, they had 3 maximals. This is maximal, this is maximal, and this is maximal. These are all maximal. There is no greatest, there is no largest. This is not largest because it is not larger than this.
Because these are the sets,
yeah,
not any values.
Yeah, but there is a least here,
least.
Because I have not thrown this out. If I throw this out, then there is neither largest nor least. But there are always going to be in a finite
maximal and minimum.
But if you have an infinite poset, you may not have even largest. For example, take integers. There is no largest integer. right? Any integer,
will be
you take
infinite.
that plus 1, that is larger.
Mm. Yes.
Sir, you have said that if I have any doubt, I ask you on Quora. So can I get your Quora name
Not
or
on Quora. There is a
Forum.
discussion forum associated to the course.
oh NPT? Okay, 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 sir.
Yeah, yeah. There is a, if you go to the course, there's a tab which says ask a question.
Yes, sir. Yes, sir. I know.
Yeah, so
Okay,
just ask there. And
okay.
the advantage is that if you ask there, there are 2 teaching assistants and they will answer the questions, and also I can answer the questions, and also others can you can also answer other people's questions there. So that's
Discussion.
also perfectly good. So
The
share
section of
your,
ask doubts.
yeah, you can ask doubts, you can discuss with others, and the only thing is don't post the answers to questions there, but you can of course discuss how to solve a question. That is fine. So,
Okay, sir.
so others, there are some students who have not said anything so far. Maybe if you have any questions. And on YouTube, if you have any questions, you can just type them. Okay, so maybe it seems like for now there are no more questions. We'll try to have one more session after 2 weeks. If you want, we can also try to have one next week. In that case, just you can,
Yes, sir.
you can ask the questions on the forum, and you can also ask if we can have another session. No problem.
Okay, sir.
Okay, so maybe we'll end this here. It was nice meeting some of you.
Thank you, sir.
Yeah.
Jai Hind.
Okay, Jai Hind.